Good morning, ladies and gentlemen. Welcome to Good Burger, home of the Good Burger. May I take your order? Today we're going to be generating equivalent ratios, which is an extension of yesterday. Now that we understand what ratios do, a little bit more about how they function, we can use some of our knowledge about multiplication and division to kind of extend these ratios to help us solve problems. And so, an equivalent ratio is just a ratio that express the same relationship, so that they are equivalent. They work very similar to equivalent fractions. So even though the digits might be different, they express that same relationship, right? They are worth the same amount. Using multiplication, we can find equivalent ratios in one of two ways. The first way we're going to talk about is by using a table. In this particular case, you notice that we are comparing basketball players to soccer players, and that it looks like for every 16 basketball players, there are 48 soccer players. And so the idea here is that we are going to multiply both terms of the original ratio. So this is term 1, and to get to term 2, they multiplied both by 2. And to get to term 3, they multiplied both by 3. And what I mean by that, what I mean by multiply both is, you'll notice here, if we take the first term and I multiply both by 2, that it just so happens I get the second term of 32 basketball players and 96 soccer players. So that's, you can use a table to kind of continue to extend the ratio. Similarly, right, we can set it up like a fraction. Again, you'll notice this fraction here of 16 over 48. That's basketball over soccer players. And if you multiply both by 4 over 4, right, which is equivalent to 1, and you'll remember that anything multiplied by 1 keeps the same value, you end up with a new ratio of 64 over 192. That's 64 basketball players to 192 soccer players. But it's an equivalent ratio. Okay. So I'll do the first one with you, and then we are going to do the next two on your own. So the first one says, if you extend the table above, and I've copied the table at the bottom of the screen here, but it's in your notes, what is the next ratio of basketball players to soccer players? So we're basically asking you, right? They're asking you, if we added on another box here, what goes in the next box? And so we've multiplied by 2, by 3, by 4, so the next arrow would just be times 5. And so you'd have 16 over 48 times 5 over 5. Notice that I'm not just taking the box before. I'm not just taking 64 and 192 and multiplying that. Instead, I'm going all the way back to my my original ratio. 16 times 5 is 80, and 48 times 5, let's see here, 5 times 40 is 200, 5 times 8, so that would be 240. Okay. Similarly, I guess you could have also noticed that there is an addition relationship going horizontally between those terms. Pause the screen and try 2 and 3. All right. Number 2 is a little bit tricky because they're using the same ratio of 16 basketball players to 48 soccer players, but they've switched it and given you the total. So here in problem 2, I actually wrote a new ratio here of soccer players to total players, which is 48 soccer players to 64 total players. I got 64 from 48 plus 16. And then I tried to figure out, well, how did I get from 64 to 448? And you can see a little bit of a guess and check over here. And once I figured out that that was times 7, then I multiplied the top of my ratio by 7 as well to get 336 soccer players. And in problem 3, we're looking at the relationship between players in each column. And so that is kind of a guess my rules situation here, where we are actually going to be looking, we're going to have maybe some technology, nope, there we go. Right, we're actually looking vertically here. So I rewrote these ratios just to give myself some space, and I found 16 over 48, 32 over 96, 48 over 144, all had the same relationship of times 3. 16 times 3 is 48. 32 times 3 is 96. 48 times 3, let's check. So that's 24. 12, 40 is 144. Right, and that's how I got this, that there are always 3 times as many soccer players. Flip side, using division. It works the exact same way, except you're working backwards here. They've given you a ratio here of 18 shots taken to 12 shots made, right? Or 18 over 12. And now you're dividing both terms, right? Again, we're working to the left here. Right, divided by 2 or divided by 3. And again, here with a fraction, you'll notice that they're just dividing the top and the bottom, written as a fraction, both by 3. So here are some for you to try, and I would encourage you to pause the screen and try them both. All right. In problem 1, I've set up a ratio here of tomatoes over onions, and she uses 8 cups of tomatoes for every 3 cups of onions. So if she uses 4 cups of tomatoes, how do we figure that out? Well, to get from 8 to 4 here, I've divided by 2. So down here, if I divide by 2 as well, I either get 3 halves or 1 1/2 cups of onions. So the answer here will be 1 1/2 cups of onions. In problem 2, we're looking at which of the following ratios are equivalent here. I started here by simplifying this ratio as much as I could, and I used some fraction knowledge. I divided 16 and 20 by the greatest common factor, which was 4. And I did 16 over 20 divided by 4 over 4. That got me 4/5. So I knew that was going to be the case. I know that 4/5 and 2/3 are not equivalent, so I know that it can't be 2/3. And then what I did was I took 4/5 and I tried to see if I could get 4/5 to either equal 18 to 22 or 20 to 25. And it just so happens that I could get it to equal 18 to 25. So that was my other answer. You'll notice in all of these problems we're using multiplication division. We're also using a lot of fraction knowledge. So if you have some questions, please come and see me. Otherwise, you're completing 5-2. And have a great day.